So hello guys, and I'm Anjum Rashid. I'm a student from Jahangirnagar University, and I'm an undergrad of Computer Science and Engineering department. I do usually cloud computing stuffs and also some information security stuffs. On on my session, I would be speaking on basically cloud and virtualization, and I will be showing you how the combination of these two technologies is creating the ultimate awesomeness that we are experiencing every day. And let's start. So here's my quick profile. I'm a infosec enthusiast. At the same time, I've been contributing to open source repositories for like 1 year. I do some blockchain stuffs, and also I collaborate with communities. So first of all, I'm an ambassador from Microsoft Learn Student Ambassadors community, and recently I've been working with Postman, and also I'm their Postman student expert. And as for content writing engagements, I've been working with Voice of Code, which is a global blogging platform. And finally, I'm the General Secretary of Geo Computer Club, which is a technical club based on Jahangirnagar University. Let's get going. So starting with a bit of nostalgia, and this is related to console emulation. So have you heard about Game Boy Advance? I guess
Yes,
most of you have. Right. So this was the ultimate, I should say, ultimate gaming console
I get.
back in 2005 when Nintendo introduced it, and we were really loving the concept of having a console for playing your favorite games, maybe Pokemon or something else. But as the time progressed, and as these type of 2D gaming consoles, they really got deprecated, and on modern times we've been using some kind of a solution for having that bit of nostalgia using something called an emulator. So I don't know if you guys have heard of Visual Boy emulator. That is kind of like a software you install on your PC, and that is used for playing the exact same games that you would play on the Game Boy Advance emulator, or say something else like PS2 or PS3 or those type of consoles which have been deprecated already. So the first question that you should ask, that is, what is the emulator, or what is the purpose of this emulator? How is that doing this type of stuff that is exactly same as the physical hardware over here? So I will be talking a bit more about that. And here we can already see that gaming console emulators perform hardware virtualization by emulating a video game console's behavior. So here comes the term hardware virtualization and the emulation. So first of all, we are already understanding that this particular emulation topic is related to something called virtualization. And as far as you are concerned, that I would be talking about talking a lot about these virtualization steps. So this was just a case study, just an example, just to get you started with the idea of virtualization. So let's get into the main topics. What is virtualization? So over here, I have a definition from Red Hat, and they're saying that virtualization is basically the technology that lets you create useful IT services using resources that are traditionally bound to hardware. So what are the IT services? Can anyone give an example? IT resource or IT service? Kaiser, Asif, anyone?
Okay, it could be like IT hardwares like RAM, processor, processing power. It could be fall under the hardware resources. And if I talk about the software resources, it could be like some solutions that's working underneath the system or infrastructure.
Exactly. So basically these IT infrastructures or IT services or IT resources, we are basically referring to hardware components like RAM modules, or something like computing power, that is the CPU, then storage, then networking, and all these type of stuffs. So basically virtualization is the act of creating a virtual version of something, such that it is something like a virtual computer hardware or a virtual storage or a virtual networking solution. So what do we mean basically by this virtual term? Something that is not physical, right? Something that you can touch, or something that you cannot see in mere eyes. So as for virtualization exists, we usually intend to use something that is not basically physically visible, but we can understand that it is right there. You're right, interacting with it. It is such a entity that basically you have the opportunity to interact and make something out of it. So here companies could partition their servers and run legacy apps on multiple operating system types and versions. So first of all, why would company partition their servers, and why would they need, why would they were requiring the use of virtualization? So on the right side we have an example. I have also took this from Red Hat, so they have really good examples over there. Say you have 3 servers and each of these servers have their own operating system, like usual ones. Suppose this is a Windows machine, this is a Linux machine, and this is the Mac machine. But the catch is that the every single isolated machines are being used for specific purposes. The first Windows machine is used for mail purposes, the second machine is used for web purposes, and the third machine that is running the legacy apps is running on Mac. So the catch is that 3 of these machines, all of them have one same property, that is they are using only 30% of its computing resources. Okay, so let's say they have like suppose they are running over Intel Core i5 CPU that has 4 cores, but at one time they are using only 1 core. So the remaining 3 cores are not being used. So what would happen if you incorporate virtualization technology on it? So what would happen is that, say for example, on the Windows machine, you install something like something that is called hypervisor. That is a software. You just install it on your operating system, and that lets you provision and manage some other operating system other than your current operating system. So the legacy apps, say that those apps were being run on Mac operating system, but on Windows machine, using a hypervisor, you get the opportunity of using that particular Mac operating system into the Windows machine, such that both of those machines are running together. So as we already know, that server was basically taking 30% of the CPU. So if you combine those both into a single machine, you would be running both of the functionalities together. So on the first machine, which was the Windows machine, it is running both the applications together like it's a single machine. But actually in particular, or should I say in practical, both of these applications are being run on their own virtualized operating system and own virtualized dependencies. So virtualization's widespread applicability made it to the foundation of cloud computing. Right now we are talking over a seminar or webinar on cloud computing, but this essence of cloud computing which we were talking about, it basically came right from that virtualization technology, which enabled it to further extend its capabilities. So moving forward, and we would be knowing a bit about the types and variants of the virtualization technology. First of all, we have storage virtualization. That would mean that you have the option to virtualize a storage system such as virtual disk storage, or say solid state drive that we usually buy from our market vendors to basically extend our capabilities, right? So if you virtualize storage, you would be having your own virtualized SSD or hard disk drive, and that would be awesome because you would have the option to buy or use that particular solution using a cloud computing provider. Okay, so moving forward, we have OS virtualization, and this is the most popular form of virtualization that we know today. So as for OS virtualization, we will be virtualizing the entire operating system and its architecture. We have that basically allows us to run both Linux and Windows environments side by side, and that is really awesome. For example, on my machine, if my screen share is being shared properly, I can show you that I have Oracle VirtualBox, and basically this is a software which gives us the option to run multiple machines together. So as over here on the interface, if you guys can see over that, can anyone confirm?
Yes, we can see it.
Yes, you can see it. Right.
Okay, so on the first, on the top over here, we have Kali Linux machine, which is basically a Linux machine, a machine running on Linux kernel. And also we have something called Drill 2020. This is basically a Ubuntu machine. So I'm on Windows machine, but at the same time, I can run a Linux and a Kali Linux and a Ubuntu machine together. And that is awesome. even if you want to run something like Mac or any other operating system like FreeBSD, you also have that option over here. After that, we have desktop virtualization, and this allows you to deploy simulated desktop environments such as VDI. VDI means virtual desktop infrastructure, and this is kind of like a subdomain to desktop virtualization. And as for this particular subdomain, you have something like you guys may have heard about the RDP protocol, remote desktop protocol, which allows you to basically control a PC from a remote PC. You may have heard about TeamViewer or something like, I guess, okay, AnyDesk. So TeamViewer, AnyDesk, this type of solutions are being run over RDP protocol, and they basically fall under VDI subdomain. Okay, so you are deploying multiple desktop environments. So suppose you have a script that lets you to provision a particular type of operating system with particular type of applications on it. So if you have that particular script ready and you have hundreds of physical machines at your disposal, you would be running just the same script over each of the virtual machines, and it would take around 5 to 10 minutes to provision the machines and at the same time configure them automatically. So that is giving you the utmost flexibility and also the reliability that you're looking for on a cloud computing platform. Moving on, we have server virtualization that lets you to virtualize a server. That could be a web server, that could be a mail server or something else, and they're doing the same stuff just like these desktop or OS level virtualizations. And finally, we have network virtualization, and that is virtualizing just the network. And speaking of network, here come the terms like IP, here comes the terms like routing, switching, and subnetting, these type of stuffs, right? So talking about Azure, we have something called Azure VNet or Azure Virtual Network. So if you provision a virtual network on a specific region, you have the opportunity to basically combine different type of Azure services and Azure solutions over your newly created virtual network, and you would be able to maybe build your own custom system based on, maybe you're running a startup, you are maybe looking for something similar to Uber. It would be giving something like ride sharing service. So your system components, you would be just picking out your components from Azure services, and then you would be combining them through a network, an Azure virtual network. So these are basically the types, but also if you search over online, there would be you might find something else or something more, some more types of virtualization, and that is totally fine. I have just picked the most important ones so that you can get started with cloud computing right away. Here are some common terms related to virtualization, and on the top we have something called hypervisor, and it's a pretty common term, and you need to understand what a hypervisor is. So basically it's the program or the software that creates a virtual machine on the host hardware, and here are some examples. But what do we mean by the host hardware? So the host hardware is basically the infrastructure that is physical, that you own. Suppose you have your own machine. For example, I have my own Windows machine over here. It is running over a Intel Core i7 5450 CPU and maybe 8 gigs of RAM. So this is the physical portion that I have bought. But if I install something like a hypervisor program, for example, this Oracle VirtualBox, I can spin up easily a Kali Linux machine or a Ubuntu machine in seconds, right? So hypervisor is a program that allows you to basically decouple your operating system from your hardware. So you're decoupling basically you're decoupling this Ubuntu machine from my own Intel Core i7 CPU, such that it is running on another CPU or another hardware dependencies. It is creating its own network interface card, and it is creating its own subnetting and own DHCP servers. Those are all virtual, and those all happen under the supervision of this hypervisor. Okay, so next up we have snapshot, and just like camera snapshot that we take on our on any occasion, what does a camera basically do? When you take a snapshot, it creates a fixed state that has the images of those particular peoples on that particular state, right? So as for virtual machine images, or as for virtualization snapshot, we would be referring to kind of the similar topic over here. So this is a state of a virtual machine, and basically this state contains the current state of its storage devices. So maybe you have some applications installed on your storage, and maybe you have some configurations running over that. So when you take a snapshot of a specific virtual machine at a specific time, the entire state would be saved into a snapshot. It is just like a file, and that file is called, sometimes it is called the disk image, virtual disk image, and the format is called VDI. So that snapshot allows you to revert back to a specific moment when your virtual machine may be malfunctioning, or maybe on Windows you have something called blue screen of death. It's a problem, or it's an issue that occurs on Windows machines usually. So when you have something like operating system issues going on, you would be trying to reverting it back to a specific state so that it can function properly, right? So snapshotting your particular virtual machine allows you that capability. After that, we have migration, and by migration we mean like leaving one country and moving on to another, right? So it is just like the same concept. You are leaving one host machine and you are moving on to another. So suppose I'm on my Windows machine, it has its own hypervisor, that is my Oracle VirtualBox, and on Asif's machine, which is located on somewhere else, he is running, say, VMware solution, VMware workstation. It is also a hypervisor. So on my machine, I have a particular snapshot of Kali Linux machine, and I need help about, maybe help about installing some particular application. So I'm asking Asif if he could do that on his machine using my snapshot. So I would be snapshotting my particular state, and I would be sending this snapshot, which is basically portable, and Asif would be importing my snapshot into his hypervisor, and he would be able to provision that particular state of that particular operating system right away. And that gives you the opportunity of portability, right? You can easily portable a virtual machine from one PC to another PC, or maybe it's not about residing on PCs. You can basically take this piece of software from any type of infrastructure you may think of. And finally, we have nesting. This is an interesting topic, and not every virtualization hardware allows this. This is kind of like, suppose I have my Windows machine, and under it I install Oracle VirtualBox as hypervisor, and I provision a machine, say it's Kali Linux. So the Kali Linux is called the guest OS. It is acting like the guest one, and Windows is acting like the host one, who is welcoming, like, come, you have the opportunity to run over my infrastructure. So what if that guest machine, that Kali Linux machine, is running some other hypervisor, and it is provisioning its own guest machines inside it? That would be called a nesting situation. So not most of the CPUs allows you to do nesting, but there are some specialized CPUs. You can make 2 or 3 level nesting if you want, but be aware of the fact that whenever you are nesting and whenever you are creating a guest OS, it would usually take its resources from the host OS. So the more you are nesting, the more your guest OS would be slow, and it would give poor performance. So moving on to the containerization, and it has already been described by Kaisar, but I'll be just touching the key outlines over here. So containerization means a process which encapsulates an application and all its dependencies into a container with its own operating environment. This own operating environment doesn't necessarily mean that it would require an operating system. It would be just like anything. So what is this encapsulation process, right? When you are running a virtualized machine or a virtualized guest environment, say 2 specific environments, one is Ubuntu, other is Fedora, onto your own machine, both of the environments are isolated. So if you try to say if you install VLC media player on Ubuntu, it won't run on it won't be available on the Fedora machine, right? Because the Ubuntu and Fedora, both of them are loosely coupled, and they don't have any connection together. So when you are containerizing something, it is encapsulating its own dependencies and its own contents such that the other sectors in the hard disk that it is installed on, it won't be touching, or it won't be connecting with other the other regions of your hard disk. So say you're running a container on your machine, and on your machine you have some applications installed. You can be really sure that your installed applications on the host machine won't be available on your container, and that is because of this encapsulation. And moving on to the next point, that is called the portability from one computing environment to another. So the reason for using this containerization scheme or technology is basically for the portability. Say you have you are developing your own system, and that has maybe .NET infrastructure. You are maybe using for Angular for front end, that is the JavaScript framework, and say you have set up a server, that is the IIS Microsoft server. So when you are running or when you're developing on your own machine, that is going just fine. But when you're deploying it onto a production situation, you would usually find some bugs and issues that is solely because of its machines or hardware's architecture. So how to solve this issue? How can we basically decrease the number of bugs that happen in the production? If you basically do your development works under a container, and then when you are when you have done all the testing and QA stuffs, then you can easily deploy you can just spin up this specific Docker container onto your production machine that would have the exact snapshot of the machine that you're running on your development environment. And you won't have any architectural issues or hardware issues that you would typically face. So this is the portability feature of this containerization technology, and it allows you to deploy multiple applications using the same operating system on a single virtual machine. So you have Windows machine, you would be Docker allows you to spin up maybe 10 or 20 or 50 or 100 machines at the same time. But for that purpose, if you're going for a large number of machines, you would better if you use Kubernetes. That is the best solution for that, and that is the orchestration scheme for deploying or provisioning a large number of Docker containers at the same time. So basically, Docker is a popular containerization platform. And why are we learning about containerization? It's a virtualization webinar, right? That is because virtualization is something that has been on that has been available since 1960 when it was first introduced. So it's been a long time that we have a long history with virtualization, but right now people are moving towards more into containerization. It's a bit different technology because when you're virtualizing something, you are basically the guest operating system is working on its own guest resources. But as for containerization, all the operating system is the same. I'm running my own applications into the isolated containers. But as for virtualization, apart from the applications, I also have to install the operating system and maintain the operating system, right? But the containerization basically takes away that hassle of maintaining your own operating system into the containers. You can have your own Windows host machine, and that would be providing you the resources to run the containers over that. So here we have our main topic, that is the cloud virtualization, and how is cloud adopting the virtualization scheme to scale to basically be more economical and more efficient. So cloud virtualization has transformed the traditional computing scheme. Back in maybe 1980 or 1990, back then cloud were not something prevalent back then, right? So cloud is something a recent invention. It's been really popular in recent times. Back when some providers used to provide some hosting or some other computing services, they would usually provide something physical hardware, right? So they would be purchasing, say, 50 CPUs, then maybe 100 RAMs. So starting from slide 9, so basically the cloud virtualization scheme that I was talking about. So cloud has basically incorporated this particular virtualization technology such that the traditional computing and traditional technology that was prevalent back then, it has enhanced it in such a way that that makes the cloud computing more scalable, more economical, and efficient platform. So how does it incorporates this particular virtualization scheme, right? So basically this the scheme is implemented such that all the users they can share the same cloud infrastructure through virtualization. It is like the glue that is sticking all over the cloud infrastructure, and that is basically the the I should say that that is the main the main gluish element that is um, combining all the network and all the cloud services into one single platform. Over here on the right portion, we have maybe, for example, just think about like a cloud provider, or maybe you just think about yourself. You have your own startup that is supposed to give some cloud providing solution or something like that. So you would be basically buying some hardwares. Those are the physical hardwares. These are not virtualized solutions. So you are buying one CPU, not one. You'll be buying multiple CPUs, multiple RAMs, and storage and network devices. So you have all of these hardwares into your own data center, and a data center is basically a building that has all these mainframe computers that is containing all these these physical resources. Okay, so on the top of this hardware, you are installing your host operating system, and you'll be installing basically the lightweight kernel version of it. And over your host operating system, you are installing the main brain behind this virtualization technology, that is the hypervisor. And for our case, that is something like Oracle VirtualBox. On the top of hypervisor, you have the opportunity to run multiple virtual machines onto your same same machine or same server. So here you have one VM, and under your VM you have your virtualized operating system, and under your operating system you have virtualized applications. So this is basically just done over a couple hundreds or thousands of times, such that on a data center there are like literally thousands of virtual machines running at the same time, and it is basically starting and stopping on demand basis. So whenever you have maybe 500 customers in one day, and on the later day you have just maybe 10 customers, based on your customers needs, the virtualized environment is getting expanded or shrinked. It is based on your need, and that is why we are moving towards cloud computing. That is the main purpose behind using this cloud computing technology. And this is basically incorporating all the operating system, hardware, server, network, and storage virtualization schemes, just like I have talked about before. This CPU, using this CPU, when you are hypervising some specific virtual machines, that would have its own particular type of CPU, and thus you are virtualizing the computing resources. And at the same time, you are virtualizing the hardwares, the storage solutions like this solid state drive or hard disk drive, and also the virtualized network adapters. So how does actually Azure work? Whenever you try to provision a virtual machine, so right now we already know what a virtual machine is, right? Virtual machine is the virtualized environment that you create on your own host operating system. So as for Azure, you are creating the host operating system is on Azure's data center, and Azure has maybe 160 data center all over the globe. I might be wrong, and it might have expanded in the meantime, but on each of the data centers you have the flexibility to specify on which data center and on which region you want to provision your virtual machine in. So say you are provisioning, you are taking a virtual machine space from India, and you would be creating a specific virtual machine for your maybe academic project need. Fine. So for that purpose, you would be just clicking something on Azure portal, just like Kaisar has shown you and Asif would be showing you onward. So whenever you're clicking something or clicking on create a virtual machine or configuring some information on your web browser, what it does is that on the backend, on the actual data center, there is something called a orchestrator and something called a hypervisor. So you already know what a hypervisor is, right? So on the data center, Azure data center, there are racks of servers, and on each server rack, there is one orchestrator which is basically the fabric, which is basically the brain behind all of this automation stuffs. So whenever you're clicking something on the front end portion on your website or web browser, like creating a virtual machine, that particular signal or that particular command is sent over to that orchestrator, and which is the brain, and he say orchestrator is a person, so he basically just gets the request of creating a virtual machine, and then he thinks, okay, so I need a virtual machine that has these particular configurations. So what would I do? I would pick one CPU. I would pick maybe 250 gigabytes of storage, or maybe something like that. I would need a RAM. I would need a networking adapter, and finally, when I have all of these particular computing or basically computational services ready, I would be just combining them, all of them, into a specific virtual network. And finally, when all of this infrastructure, all of this system have been deployed properly, I would notify the user. That means you who's trying to create the virtual machine, you see something like your virtual machine is created, and now you can log on to your machine. Now you can work just the way you want. So this is how basically an Azure data center works when you try to provision a particular service. That is not only limited to creating a virtual machine. You can create anything, just like a machine learning solution in the cloud for your particular purpose, or you can maybe provision something to play some high spec gaming. Maybe you're trying to run Cyberpunk 2077 on your machine, but your PC is basically a potato crap, and you can run anything on it. So you can easily provision a gaming solution on Azure and install Cyberpunk over there. Then you would just be logging onto it, playing it, and it would all require just a little bit of good internet bandwidth, and you're good to go. So that's all from me, I guess. And this is what I wanted. Basically, I wanted to make you guys introduced with the technology of virtualization, and how it has been connecting all this cloud computing technology with general masses like us, right? So here I have some of my socials over here. You can connect me over LinkedIn. You can text me over Twitter, and finally, also I do some content writing, so you can find me over Medium too. Thank you, everyone. And